So I have given 2 ebooks in the Google Classroom. So if you follow the Swarm series book, then it is chapter 1, chapter 5. And if you follow Rogen's book, then it is chapter 6. So actually, those who are from mathematics background or any other background, those who have completed class 12, you have studied permutation and combination in class 11, I guess. So here we'll discuss the permutation and combination in perspective of counting. So permutation and combination is nothing but how we can rearrange certain numbers to find out the total number of possibilities. So for example, the problem of counting has started with actually a gambling problem. So for example, you are playing the game of cards. So at any point of time, you need to provide one say spade. Then how many spades you can have, or how many spades your opponent can have. From that, you can actually identify which sort of actually step we will be taking in that particular or at that particular time. Otherwise, say for example, if I consider, say for example, you want to give a password in your PC. So if you want to give a password in your PC, let's say the password will be of uh, length 6. So here, say let's say there are 6, the password length of the password is 6. So here you will be providing the password, or you will be identifying the password in such a way that it will take one the uppercase, it will consider one lowercase, and at least one uppercase, and at least one lowercase, and at least one digit. So in this way, you want to give the password of the PC. So here, what sort of possibilities can be there if we want to identify? So, say person A can give one sort of password, person B can give another password by satisfying this characteristic. So, what can be the total possibilities that one can give the password of password of length 6 for each PC? Say let's say we want to identify. Then here also we need to consider the counting. So here counting is not a fixed counting, rather all possible sort of counting. So from that there comes the permutation and combination. So can anyone tell me what is the difference between permutation and combination? Just in a simple sentence. So counting is clear. What is the counting? Counting means uh, here we are not actually wanting to count the number of things. Rather, we want to count the total number of possibilities. So that is the main mode of counting. So from that, there comes these two things: permutation and combination. So what is the difference between permutation and combination? Just in one sentence, or just simply, what do you mean by the difference between permutation and combination?
So permutation is how we arrange different objects, and combination is the number of ways to choose um, from the.
So while you are arranging something, let's say you are arranging something, say 5 books are there, and you want to arrange these 5 books in a book set. So here also, in order to arrange books in a book shelf, actually there are 4 places you want, or 6 places you want to arrange 5 books. So here also you need to choose one book because there are 6 places, so you want to arrange 5 books. So which book you will choose for filling up a particular portion of the shelf? That also you need to choose. Is it not so? Whenever you are arranging something, then some objects will be there with you. So you want to arrange those objects. So to arrange those objects, if you want to fill something, then you want to choose some object first, then followed by the next object, then followed by the next object, and so on. So what is the difference between that? Because permutation is also a process of choosing and then rearranging. So what is the difference between this? Have you got my question? Have you got it or not?
So please repeat once the question.
So what she has told that permutation is actually, so I want to say that what is the difference between permutation and combination? So someone amongst you has told that, she has told that the permutation means, she is right, the permutation means the rearranging something, and combination means choosing something. So while you are rearranging, let's say the book shelf consists of 5 blocks. So you want to arrange 4 books. So while you are going to arrange 4 books, first you need to identify which book you will choose, then in which block you will place that book. So you need to choose that also. So that is also a process of choosing. So what is the difference between then permutation and combination? What she has told, she is right. But there is a basic difference. Permutation is also choosing. We are choosing and rearranging, and in combination we are choosing. So what is the difference between that thing?
Sir, in combination, the order of the elements actually does not matter.
Yeah, yeah, that is actually the main thing. So while you are doing the combination and permutation, order is not matter. How we can say? Say for example, I have actually taken 2 jackets. So one jacket is of color red, another jacket is of color blue, and there are 3 persons, uh, or there. So I have taken say 3 jackets. Say one is of color red, another is blue, another black. Then there are 2 persons whom I want to provide these 3 jackets. Now, while we are trying to provide these 3 jackets to those 2 people, then only the color matters. Whom I am giving this doesn't matter. But while we are choosing the permutation, or while we are considering the permutation, the color of the jacket matters, as well as to whom I am giving that color of jacket is actually mattering. Is that clear or not? Have you got it?
Yes, sir.
Yes, sir.
That means,
স্যার
say for,
একবার একটু
sorry, are you saying something?
স্যার আরেকবার এটা একটু বলেন মানে
Okay.
রিপিট করেন
Yeah, yes, yeah. Say for example, there are 3 colored jacket. So jacket 1 is color black, jacket 2 that is color red, and jacket 3 that is color blue. So I want to give this 3 jacket to 2 persons, person 1 and person 2. So while we are considering the combination, then what happens? Just I am concentrating on either jacket or the person. So if I concentrate on the jacket, then I can provide only 2 jackets. That's why, say jacket 1 I have chosen, jacket 3 I have chosen, but whom I am giving this doesn't matter. I can give jacket 1 to P2, jacket 1 to P1, I can give jacket J3 to P2, J3 to P1, but that doesn't matter. So just I am choosing 2 jackets out of those 3 jackets, and to whom I am giving this doesn't matter. Is that clear? Is that clear or not?
Yes, yes, sir.
And in permutation, what is mattering actually in permutation? So I'm choosing say jacket 1 and jacket 3. So after choosing the jacket 1 and jacket 3, it matters also to whom I am giving these jackets. I can give jacket J1 to P1, or I can give jacket J1 to P2. Similarly, I can give jacket J3 to P1, I can give jacket J3 to P2. So these 4 cases will be there. That means while I am giving or choosing 2 jackets out of those 3 jackets, and to whom I am giving, this is actually mattering when I am considering the permutation. But when I am considering the combination, only it matters that I am choosing 2 jackets out of these 3 jackets. But to whom I am giving, this doesn't matter. Is that clear? Have you got it or not?
Yes, sir.
ইয়েস স্যার ইয়েস স্যার
So this is a simple example. Otherwise, if I consider numbers, let's say there are A, B, C. So from these 3 numbers, I am choosing 2 numbers. So here I am choosing, that is called the combination. Combination means combination of the elements which we are choosing. In permutation, choosing as well as arrangement. This matters. That means three things are there. So in both these cases, I am selecting 2. And here how I can select? Either I can select AB, or I can select BC, I can select CA. Is that clear? Is that clear?
Yes, sir.
But here what I am doing? Here I am choosing AB. Then A first, B second. Then I am choosing AC. A first, C second. I am choosing BC. Means B first, C second. Then arrangement means after choosing these two, I am arranging whom I am choosing first and whom I am choosing second. That means if I choose A first, B second, then A will come first, then B will second. That means there is ordering. If I choose B first, A second, then BA will be another ordering. That means choosing A, B as well as we are arranging them in with respect to the time or with respect to the order. Similarly, AC, if I choose C first, then A, CA. If I choose C first, then B second, then CB. So here there will be 3 cases, but here there will be 6 cases. That means here I am choosing as well as I am actually considering the orders. But here I am actually choosing, but we are not bothered about the ordering. So that is the permutation, that is the combination, that is the permutation. Is that clear? Is that clear?
Yes, sir. Yes.
No. So before discussing the permutation and combination, here since these 3 things are there, I am choosing 2. Here 3 jackets are there, I am providing these to 2 persons. So that is very much easier to identify what sort of arrangements can be there, or what sort of uh, choosing can be there, how we can choose them. But if the number of things are large, then it is not very much easier for us to identify this manually. So that's why we need to establish some process of counting. So actually, to identify what sort of or how we can combine some elements or how we can permute some elements, we need to identify some rules of counting. So that's why we'll be studying counting. So in counting, there are 2 ways. One is called the multiplication rule. That is called the addition rule. So when we can use the addition rule, when you can use the multiplication rule? Say for there I am considering it for 2 cases, 2 instances. Then I will be generalizing this for more than 2 instances. Say for example, now one event is occurring in one way, that means there are n1 possibilities for one event to occur. For another event, there are possibilities of n2 to occur. So just I am giving a simple example. Say in school we have taken admission in class 5. Okay. So you need to choose 2 languages. One is language 1, another is language 2. In language 1, there are 5 cases. In language 2, there are 6 options. Is that clear? So in class 5, some student has taken admission. So there are 2 language groups. In one language group, there are 5 options, and another language group, there are 6 options. Now, if it is mentioned that either he can choose language 1 or language 2, then what can be the total possibilities? Have you got my question? That means either or. Option is there. Either or or. That means both the language groups he or she need not to choose, but she can choose anything from language 1 or she can choose anything from language 2. That means they are not happening simultaneously. Is that clear? Have you got it or not? Is that clear or not?
Yes, yes.
So how many total cases will be there? That means he has given two language groups. In one group there are 5 options, in another group there are 6 options. So he can choose, or he or she can choose only one language, either from group 1 or from group 2. So what sort of overall possibility will be there in front of him or her?
Sir, at a time I can choose one only.
Yeah,
Okay. Sir, 5C1 for L1 and 6C1 for L2.
then total possibilities?
5C1 plus 6C1.
Yeah, that means here either she can choose one language from L1 group or another language from L2 group. So total there are 11 options, because 5 options are there from L1, 6 options are there from L2. She can choose only, or she can choose only one language, either from L1 or from L2. So when this either or cases will be there, or some cases will be there where all the things are not happening simultaneously, then actually we need to use the addition rule. Is that clear? So here there will be total 11 cases. Is that clear? So here if two instances are there, this will be n1 plus n2 will be total number of cases. Is that clear for all?
Yes.
Yes, sir.
Okay. Now if it is given that two are happening simultaneously, but they are independent. That means he need to choose one language from group 1 and he or she need to choose one language from group 2. So they are happening simultaneously, but they're independent, because in language 1, if she choose or he chooses one language, that doesn't depend on the selection of the second language from L2 group. That means they are independent. Here you can choose L1 1, here you can choose L1 3, here you can choose L1 2, here you can choose L2 2. That means which sort of language he is choosing or she is choosing from L1 group, that doesn't depend on the language he or she is choosing from L2 group. So what sort of possibility will be there for total cases? That means here he or she need to choose two languages, one from L1 group, another from L2 group. So here either or is not there. Both are happening simultaneously, but they are independent. So what will be the total number of cases? Have you got my question?
Yes, sir.
That means here either or. That means he need to choose only one language, either from this or from this. But here he or she need to choose two languages. That means both are happening simultaneously, but one from this group and another from this group.
Sir,
So
5 into 6.
yeah, there will be 5 into 6. Why there will be 5 into 6?
Sir, for each language one, I can choose each language in L1. I can choose a language from L2. So for every 5, I can choose every 6.
Yeah, that means here say L1 1, L1 2, L1 3, L1 4, L1 5. So for L1 1, I can choose the first language from L1 2. That means for L2 1, here I can choose L2 2, here I can choose L2 3. For each of these, and I can choose L2 4, and I can choose L2 5, and I can choose L2 6. So if I choose this, so for that I have 6 options from the second group of language. Similarly, if I took L1 2, for this choice I have again these 6 choices from L2 group. So for L1 there are 6 choices, for L2 there are 6 choices, for L3 there are 6 choices, L4 there are 6 choices, L1 5 there are 6 choices. So if I add all those things, so there will be total 30 choices. Is that clear? So instead of adding 6 5 times, we are multiplying 5 into 6, so there will be 30 cases. So here the total number of instances will be n1 into n2. Is that clear? Is that clear?
Yes, sir.
Okay. So just I'm giving few examples. So do you have a piece of paper with you or not? Otherwise I need to write here. Okay, so let me write. So there are 32 microcomputers in a computer center. Each microcomputer has 24 ports. How many different ports to a microcomputer in the center are there? How to solve this? Have you understood the problem?
Sir, last question again. How many different ports?
To a microcomputer in the center are there. That means if you want to choose a particular port, okay, if you want to identify a particular port, then how many ways you can identify a port in that computer?
Sir, 32 into 24.
Yeah, 32 into 24, because one microcomputer has 24 ports, so 32 microcomputers will be 32 into 24 ports. So if I want to identify any port, so I can search from one computer, so there are 24 options. Similarly, I can if I can choose the number of ports from the second computer, I can choose 24 ways the third computer. Similarly, each of the 32 computers I have 24 options, so this will be multiplied 32 times. So this will be 32 into 24. So that will be the total number of ways I can choose a port. Is that clear?
Yes, sir.
Similarly, I think all of you are familiar with the function, no? Is there anyone who doesn't know function? I think all of you are familiar with the function, no? Function means one domain is there, one codomain is there. So there are few elements in the domain, there are some elements in the codomain. So function is actually the relation, or function is actually a rule that connects or joins each and every element of domain to some co-element of codomain. So here it's a 10 elements are there, and here number of elements, what is the number of elements, that doesn't matter, because more than one elements can also be mapped to a single element. But here for each and every element, that means if there are 10 elements, then corresponding to 10 elements there should be assigned value in the codomain. If there are 20 elements, then for each and every of the 20 elements there should have a definition here in the codomain. Is that clear? Is that clear or not?
Yes, sir.
So how many functions are there from a set of n elements to a set of n elements? That means here there are n elements, here there are n elements in the codomain. So in how many functions we can define? So how many function means, if I define one function, say for example here there are two elements, let's say a, b. Here there is, let's say, three elements. Or here there is one element, three elements, c, d, e. So how many functions can be there? Function means each and every element should be assigned to some elements of this program. So can anyone tell me how many functions will be there? Just think here, then you can generalize it.
Sir, aiming.
Yeah. Sorry, your voice is not audible clearly. Repeat once. Can you repeat once?
He said aim into M.
Aiming to n.
Yeah. M into S. Now, if I consider this case, so how many functions will be there? Let's say f1 is a function. So f1 must assign some values for a and b. So let's say f1 is sending a to c, f1 is sending b to d. Then f2 can send a to d, because a can be sent to any of the c, d and e. So for if a is sent to c, this is sent to d, then f3 can send a to e. So there are three options. So for each of the three options, there are three different options that b can be assigned. Say f1b, for that it is sent to c. So if there is f1b, so here f1b is set to e, here f1, sorry, f3b, and we set to c. Similarly, f4 is sent to c, f4 c, here is sent to d. So here it can be sent to e. Similarly, f5 can send a to d, f5 is sending, here a is sent to d, b is sent to e. So here b can be sent to d. Here f6 can send a to e, here f3 is sending b to c. So here f6 can send b to c. So here there are these 6 possibilities. Okay, the total number of functions will be 6. Is that clear? Is that clear or not?
Yes, sir.
Is it clear to everyone? If you have any doubt, you could ask me. Okay. So we can generalize this. So let's say there are n instances. Where each of them is offering in n1, n2, n ways respectively. If they are happening simultaneously, but independently, then total possibilities are n1 into n2 into n1. Is that clear? Is it clear?
Yes, sir.
Okay. Say, just consider one more problem. A student can choose a project from one of the three lists. The three lists contain 23, 15 and 19 possible projects. Respectively. No project is on more than one group. Then how many ways or how many possible projects are there to choose from? Have you understood the problem? So there are 3 lists where each of the list contains 23, 15 and 19 projects respectively. So no project is there in more than one list. That means if a project is here, then the project are not here and here. So what are the possible ways a student can choose a project? So what are the
সেটা
possible?
তিনটে লিস্ট থেকে একটা চুজ করতে হবে।
Obviously, because he need to choose only one project.
তাহলে 23C1 plus 15C1 plus 19C1.
Yeah. So that means here we need to use the addition rule because they are not happening simultaneously. So in that way we can generalize the sum rule. Say for example A1, A2, A3 or say AN in events which is not happening simultaneously. And there are N1, N2 and NN options respectively. That means A1 event had N1 option. That means there are 3 projects. The first project has 23 options, second project has 15 options, and third project has 19 options. Similarly, here A1 has N1 options, A2 has N2 options, and AN has NN options. So if the intersection is 5, that means AI intersection AJ is 5 for all IJ. That means here it is told that no project is on more than one group. Similarly, here also the thing which is there in A1 is not there in A2, is not there in any other events. Then the total possibilities are N1 plus N2 plus N. Is that clear? Is that clear or not?
Yes, sir.
Yes, sir.
Okay, so this is the basic principles of counting, that is the sum rule and the product rule. The next class I will be discussing what is the pigeonhole principle, what is the exclusion inclusion principle, and then I will be moving on to permutation and combination. So this is the overall portion of this last part of module 1. That is my part. Okay. Do you have any doubts or any queries regarding this? Is there any doubts? Okay, so I'll be sharing this link of the Evernote handwritten note in the Google Classroom so that you can follow it. Just let me take your attendance. So have you understood whatever I have discussed in today's class? Is there any ambiguity or is there any doubt?
No, sir.
No, sir, no doubt.
Okay. So please respond to your attendance while I am calling your names. Okay, so roll number 1, Parthipati Mollik.
Yes, sir.
2,
Yes, sir.
3,
Yes, sir.
4,
Yes, sir.
5,
Yes, sir.
6,
Yes, sir.
7,
Yes, sir.
8. Roll number 8. Okay.
Yes, sir.
9,
Yes, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Yes, sir.
14,
Present, sir.
15,
Yes, sir.
16,
Yes, sir.
17,
Yes, sir.
18,
Present, sir.
19,
Yes, sir.
20, 21,
Present, sir.
22, 23, 24,
Present, sir.
25, 26,
Yes, sir.
27,
Yes, sir.
28, 29, 30,
Yes, sir.
31, 32,
Present, sir.
33,
Present, sir.
34, 35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Yes, sir.
40,
Hello, sir. Present, sir.
41.
Sir.
Present, sir.
Just wait, let me take the attendance. Then 41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44,
Present, sir. 44.
45,
Present, sir. 45, sir.
46,
Yes, sir.
47,
Yes, sir.
48,
Present, sir.
49, 50,
50, present, sir.
51,
Yes, sir. 51.
52,
Yes, sir. 52.
53, 54,
Yes, sir. 54.
55,
Present, sir.
56,
Present, sir.
57,
56.
57, 57, 58,
Yes, sir.
59,
58.
Present, sir.
60, 61.
Yes, sir.
Is there any other left to give the result?
57. Sir, 34.
Sir, 62.
Okay, okay, 62. You have taken admission newly, no? Okay.
Sir, 57.
Yes,
No,
sir.
57 given. Anyone?
34?
34.
Yes.
Oh. Is there any other present? Is there any other who have not responded to before? Okay, thank you all for attending today's class. So just I'll be giving this assignment in the Google Classroom. That I'll be giving the Euclidean algorithm. You need to write one code, and just it will provide you the GCD as well as the values of x and y. And I'll be sharing today's handwritten class note link in the Google Class.
Okay, sir. Sir, make Tomogno host
Okay.
for the next class.
Okay, thank you. And
Thank you, sir.